Apex now has support for polychromatic sources. You can define blackbody, CIE, function-based, and user-defined tabular sources. As you can see, this file consists of wavelength and flux pairs. Other options include randomization, position, direction, position and direction, the positional range, and the cone angle. You can also set the total flux, and in this case the number of wavelengths comes from the user-defined file that we've already selected. Once added, we can also go in and right-click on the multi-wavelength node, remove it, or edit it. Here we can see the rays and flux for each wavelength of our source. Apex now has photometric analysis capability. These include illuminance, luminous intensity in cosine space, luminous intensity in angle space, luminance, chromaticity analysis, which allows us to access the XYZ and XY chromaticity and tri-stimulus values, and visual appearance. Also, we can perform types A, B, and C photometry and create isolux and isocandela plots. Let's create an illuminance plot. For any selected pixel within the plot, Apex displays the tri-stimulus values and the chromaticity coordinates. You can make plots of any of the tri-stimulus values or chromaticity coordinates by using the results set of the illuminance calculation. And here are our plots: tri-stimulus X picture, tri-stimulus X contour plot, a chromaticity X picture plot, and a chromaticity X contour plot. Apex now has a visual appearance option to display any photometric analysis in its actual colors. In this system, we have 3 emitting disks, each using wavelengths centered about a primary color: red, green, and blue. To use this feature, perform any photometric analysis calculation, such as illuminance, and then select Visual Appearance from the Results or Analysis menus. This feature provides a qualitative view of how the output of an optical system might appear to the human eye. Apex now allows for the duplication of lens and catalog light source optical components in an assembly. Looking at the component patterning options, we have linear component patterns, circular component patterns, feature-driven, and mirrored components. For this example, we'll make a linear pattern. First, we select a direction for the pattern, and then a distance, in this case 30 millimeters, and the number of instances. We'll add 2 instances to our pattern. If we look at the new light sources in more detail using the Edit functionality, we can see that there are no light source raysets associated with these, but that's easily remedied. First, we'll select the original light source, right-click, and select the new option, Copy Raysets. Then, we can select any or all of the light sources we'd like to copy the raysets to. Again, right-click, and this time select Paste Raysets. Now if we edit one of these light sources, we can see that the original light sources have now been copied over to this light source. Apex now has additional project settings to increase the visualization performance and to easily specify the total power of the optical system. In order to set the total system power, we go to Project Settings, Wavelength and Power, and we turn on Set Total System Power, in this case 100 watts. Now we'll run a trace. In this system, as we've seen before, about 90% of the power is hitting the detector, and approximately 10% of the power was in rays that were absorbed. As you can see, the total flux in the system is now approximately 90 watts. Also in project settings, you can use the new Ray Trace display option to set the total number of displayed rays. In this case, let's change 800 to 400. As you can see, the number of rays displayed is significantly reduced. This helps to optimize the graphics performance of Apex without having to repeat any ray traces. Apex now has several new chart features and customization options. First, users may now create section graphs directly from picture plots by right-clicking in the desired section view and selecting Create Section Graph. Second, Apex now allows the labels on the picture plot power scales to be interactively edited. You can use the Power Label option to change the text that's displayed in the graph. I'll hit OK, and we can see the label value is now changed. Third, Apex now allows optional contour lines to be displayed in the picture plot. In addition to showing the contour lines, you can specify the number of levels. Finally, Apex now has an option for showing all the rays when using the Path Analysis interface. In addition to polychromatic source creation and simplified source duplication, Apex now has several other source creation enhancements. First, additional support for non-orthogonal grid sources has been added. I'll now randomly change the orientation of each of the grid sources. And we'll rerun the trace. As you can see, grid sources with diverging or converging rays that use either source perpendicular or source coordinates can have any orientation. Second, the Apex Light Source Wizard now supports adding wavelengths to light source instances by specifying the total number of wavelengths. New wavelengths are evenly distributed between two selected values. Apex now has support for assigning multiple emitting data files to a single object. The file formats include .dis, .ies, and illumdat.ldt files. As you can see, we have multiple emitting data files, and these have now been added and associated to the object. Finally, Apex now has the ability to ignore emitting rays without ignoring the geometry that they are emitting from. This allows you to turn off emitting rays while still considering the geometry during the ray trace. And that's an overview of the enhanced capabilities in Apex.